All right, so now we have a infinite series, and we're going to figure out if this converges or diverges, and we are going to use the direct comparison test. So first of all, we have to figure out a good series that we can directly compare this to. Number one, we need to make sure that it's a series that we know. So the best series to use for this one would be comparing it to 1 over the root of n, because we know that this is a convergent P series. So hopefully everything works out. That doesn't mean it's going to necessarily work out, but we now have to compare the size of these series. So we need to figure out if which is greater, 1 over n to the 1/2 or cosine n plus 2 over n to the 1/2. So first of all, just think about what cosine is. Cosine is the graph just looks like this. Everybody knows that. The important thing is, though, it ranges from 1 to -1. So if you add 2 to the cosine graph, it's going to shift it up 2. So it's going to range from 1 to 3. It's going to look like this. So cosine of n plus 2 is always greater than 1, which means since this numerator is greater than this numerator, and they have the same denominators, that means this expression is always greater than or equal to this expression. And they're both always positive, so that means this series that we know is always less than this. So if this converges, that will tell us nothing about this. However, if this series diverges, it will, since it's always less than this, it would force this to also diverge. Well, on a P series, since n is equal to 1/2, or P is equal to 1/2, which is less than 1, we know that this diverges. So since this series diverges, that will force this series that's greater than it to also diverge. So since this diverges, so does this. So we're done. Now, for some reason, it was the other way around, which it wasn't. But say we found this function to, maybe it was cosine n minus 2 or something like that. We'll have to think about that one. But if this was always less than this series, and this series diverges, well, that tells us nothing about this series. So luckily, it wasn't like that, and we could come up with a nice conclusion. So that's an example of using a direct comparison test.